Hello, welcome back to Functional Programming course. My name is Dmitry Soshnikov, and today we will talk about one more way to deal with the collections of the same type, namely streams. Let's recap the ways that we have learned so far. So lists is the simplest way to represent values in memory. And suppose we have those lists of values 1 to 3. We want to map them multiplying by 2 into 2, 4, 6, and then do some kind of fold together to multiply them to get the result 48. So the way it is executed on lists is that each operation, like map, constructs another list in memory. And then final operation fold, which needs to accumulate all elements, operates on this structure in memory, producing the result. That is really simple. Now, how does this work when we deal with sequences? In sequences, we do not create any structures in memory. So what we do is we create a generator. A generator is ready to return back the values 1, 2, and 3 on demand. Mapping function builds another function on top of that, and it is ready to return the mapped values. And when we start to accumulate them together using fold, we call back to this function. This function calls back to the original generator, and generator provides new value each time we receive it. We ask for it, and we produce the same result 48, but without spending extra memory. So in this case, the initiative is taken by the accumulating function. The function fold asks for each element of the sequence. But we can do it vice versa. We can start pushing values from the beginning of this pipeline until the end. And this approach is called streams. So suppose that if we want to execute something on the sequence 1 to 3, we would call some function f. So the stream would receive a function from here telling what it needs to do with the elements, and then we will call it. So the folding function, the role of the folding function would be to provide such function to this mapping function so that we can execute this function to get the result we want. So while sequences is driven by the consumer, streams are driven by the producer in this pipeline. And let's see how can we implement this in F#. First of all, let's start with the typing. So tStream, a stream of values of type T, should be a function which takes a function to be applied to each element. So the type here would be from T to unit. The function applied to the element does not return anything. It just executes on the element of type T. And the stream is a function which takes this function and executes on the whole stream. And that might be a little bit confusing in the beginning. So let's start with the example. How can we produce a stream, for example, from a sequence? Let's define a function of sequence, which will take the sequence S, and it will produce us a stream of the same type. So how do we do it? The stream accepts a function. So we will define it here. So we will say that it accepts the function k, and the function k should be applied for each element of our sequence. So we can call this function built-in function sequence iter, and sequence iter takes exactly the function which we want to apply for each element of the sequence and the sequence s. So that would be the definition of our function of sequence, which converts sequence into stream. Still a little bit confusing. Now let's do one more example. So let's define the function print, and the print would take a stream called k, and it will print the stream, like each element of the stream. Suppose it's a stream of integer numbers for simplicity, so we want to print each element of this stream k. So what does it mean that k is a stream? K is a function which accepts the function which we need to call on each element. So that is exactly what I want to do. I want to call k and provided the function to process each element, which will be in this case print f %d. So this is supposed to print our sequence. Let's see how it works. I will start with the sequence 1 to 3, and then I will convert it into a stream, and then I would print this stream. Let's make sure that it works. We need to execute this first definitions as well, and then here you can see that we are getting the values 1, 2, and 3 as a result, which is exactly what we expected. Now probably we want to insert some mapping functionality here. What would be the good way to insert this mapping functionality? So let's define the function map. And the function map would take the function f and some stream, initial stream k. And it should return us another stream. So whenever we want to return a stream, again, let's remember that stream is a function. And we would return the function of t. Now, because the driving stream in this case is k, and we need to start with that. We start thinking like this. To do something, to apply something to each element of the stream k, we need to call k and provide it the function which should be executed on each element of k, right? So let this be function of x, and x is the element of k, and we want to apply a map to it. So we probably want to do f of x, and we want to this f of x to pass it to the function t, which is the function of our new stream. So we return the new stream, which should execute function t on every element. And that's exactly what happens here. We take the members of the original stream, and on each element, we first convert the element using mapping function and then execute it on function t. Let's see how can we do it. We use it here. We say map times 2 and print, and it should give us 246. That is the mapping of streams. So that's how streams essentially work, and I will not go into more detail here. I will leave you as an exercise to define the folding function for streams or filtering function for streams. The interesting thing here is that in order to define a folding function, you would probably need to use some non-functional constructions from F#, because the way streams operate, we can call the function on each element, but in order to accumulate something, we need some kind of mutable value. That would be the easiest way to accumulate the stream. So interesting thing is, why would we want to do that if we already have sequences? Well, it turns out that in some of the problems, streams result in faster execution time. And I would refer you here to this blog post by Philip Chalfont, which analyzes both streams and sequences in F# and shows how to time them and how we can compare the efficiency and the effectiveness time of execution with streams. And also these streams, they somehow are similar to reactive programming, and you can imagine the situation when the stream originates not from the known sequence of values, but for example from the sequence of events, from mouse movements, from clicks, from users visiting a website. In this case, we can define this pipeline of processing functions and have them execute whenever an event happens. And that is called reactive programming, and it can be quite neatly defined in F# in a way similar to the stream definitions that we have just seen.